Hello guys. So I want us to quickly talk about congruent triangles. So in terms of congruent triangles, we are talking about triangles that are equal in all respect, right? So I want to make this video quick. So congruent triangles, these are triangles that are equal in all respect, right? So we have four cases, not types, it's cases. Let me fix this. So cases of congruency of congruent triangles that we have. The first one is this one, which is side. So if I can prove three sides of one triangle to be the same as three sides of the other triangle, then it means they're congruent. And then we have side angle side. So side angle side, I have to prove that one side and an angle in between and another side, it's equals to the same pattern in another triangle. We'll do that, you'll see that. And then we have angle side, whereby if I can prove two angles to be the same in this triangle, and I can also prove two angles to be the same in another triangle, I prove one side in this triangle and one side in another triangle, then that's congruency. You'll see what I mean by that. It might be confusing now, but you'll see what I mean. And then we have RHS. RHS is right angled, which means here I'll have to prove firstly a 90-degree angle, right angle. If I can prove that these two triangles have right angles, and again if I can prove that this triangle has a hypotenuse and the other one also has a hypotenuse, and also I can prove another side, and like that. So let's get into the nuts and bolts of it, right? So here we have two triangles below. The question says to us that prove the following triangles. Prove that the following triangles are congruent, right? The first thing you're supposed to do in proving congruency for me is to identify the triangles. So we're going to say we talk about this one now. What is this triangle? Triangle ABC. So triangle ABC. And I identify another triangle, this one. What is this triangle? QRP, right? Triangle QRP. That's the first thing you do for me. You identify the triangles. Now, when you talk about this triangle on the right hand side, we are going to write its details here on the right hand side. And when you talk about this triangle here on the left hand side, we are going to write its details here on the left hand side. I hope it makes sense, but you'll see that now. So for me to prove congruency here, there is only one way. And that one way is to use side. I'll show what I mean by that. So to prove congruency here, remember when we talk about congruency, we are talking about equal in all respect. So I'm mentioning things that are equal in these two triangles. So let's start with this side. I have this side AB. You see that? AB, it has three strikes, and PQ has three strikes, right? So I'm going to say this side AB is equal to the side PQ. How do I know that? It was given to me. You always provide a reason. I know that this side is equal to that side because it was given to me, right? Another reason, another aspect, I do see that this side CB is equal to this side QR because they all have two strikes, right? So CB, I write it on the left side because it's the detail about the left triangle. Oh, I messed up things here. So this is left. This is right, yeah. So CB, I write the details on the left. And then for QR will be right here, this way. And then what reason? How do I know that this side is equal to this side? It's given by this symbol and that symbol. So I'll say my reason here is that it's given. So I'm identifying things that are the same for me to prove congruency. Same thing applies here. This side and that side are equal. So I'm going to say AC is equals to what? PR. My reason is what? Given. I know that because it's given. So now what did I prove here? I proved this side with this side that they're equal. So the property that I used here is a side, right? After that, I proved that this side and this side are equal. The property that I used is a side. And then here I proved that this side and this side are equal. The property I used is a side. So in total, I used side side. Now I can make my conclusion. I can say therefore triangle ABC is congruent to triangle QPR. Oh, what is that? Hey, this thing doesn't want to work. QPR. Oops. Keeps on disappearing, guys. I'm facing a problem here. We are saying triangle ABC is congruent to triangle QPR. My reason for that, I used side. So I provide that case of congruency here. Side. We all see that. Okay, next one. So here we have the two triangles here. We have triangle PSQ. We have triangle QSR, right? We are supposed to prove that these two triangles are the same. So every time you prove congruency, make sure you use the 4 cases that we mentioned above, right? So in this case here, I'm going to say, start by mentioning the triangles that we have. So here I'm going to say, in triangle PSQ, and another triangle is what? QSR. Triangle QSR, this way. Right? I identify the features that are the same, right? You don't assume that things are the same unless it's proven that they are the same, then you do that. So this is my left triangle and this is my right triangle, right? We all see that. Everything about the left I write on the left side, everything about the right I write on the right side. So let's start here. Do you see the symbol? This symbol means what? It means PS is equals to QR. How do I know that? It was given through the symbol. That's how I knew it was given to me, right? Okay, now let's remove this detail so that I can work properly. What else do I know that is the same there? I can see this angle. You see this angle here? What is that angle? S2. So I'm going to say angle S2, right? It's equals to what? This angle right there. What is this angle? Q2. So angle S2 is equals to angle Q2. How do I know that? They gave me symbols. So they proved that these two angles are equal. It was given, right? But then I proved 2 things now that are the same in these 2 triangles. What else is the same? I look at this line here. This line that moves across there called SQ. We see that this line now, it's in this triangle and it's also in this triangle. This one here. This line is in this triangle and also in this triangle. So this line, I can say this triangle has the line SQ and also the triangle on the right has the line SQ. My reason then for that, it would be what? Common side. Right? Oh, let me write SQ there. It was erased by mistake. We all see that. Then now I can make a conclusion. After proving 3 things, that's all I need. I can say therefore triangle PSQ is congruent. You see the symbol for congruent to triangle QSR. My reason for congruency, what did I prove here? I proved a side here, I proved an angle here, and I proved a side here, right? So what is this case of congruency? It's side, angle, side, this way. We all see that. Okay, let's move on. Okay, now let's look at this one. So on this one, what do I have? I have these 2 triangles and I'm supposed to prove congruency too. What is the first step? Identify the triangles. So I'm going to say in triangle PQT, you see that, and triangle SRT. That's what I have so far. I proved things that are the same. So look at this angle here, angle P. See angle P? It has a symbol right there, So I'm going to say angle P is equals to, it's equals to what? Angle S on this side. is equals to angle S. How do I know that? It was given to me through the symbols, right? What else do I know? Look at T1. T1 right there. Angle T1 must be equal to what? To the angle T2. We are using all the reasons we can find now. Not everything is given, right? Oops. So angle T1 is equals to T2. What could make T1 be equal to T2? It's because they are vertically opposite angles. These angles are vertically opposite. They form an X formation. So if they are opposite in an X formation, they must be equal through vertically opposite, right? And what else do I know? I also see that in this triangle, I have this line QT, right? With this symbol here. So the line QT must be equal to which one? This line here, RT. So I'll say RT. How do I know that? Through this symbol and this symbol. They showed me that the two lines are equal. So I'll say that was given. It's given through the symbols. Now, after proving three things, I can make a conclusion. Now I can say, therefore, triangle PQT is congruent to triangle SRT. What case of congruency is that? Let's look here. What did I prove? I proved two angles to be the same. And what did I prove here? I proved two angles to be the same here. And what did I prove here? I proved two sides to be the same. What case of congruency is that? It's angle, angle, side. That way, right? If the case of congruency is not there, make sure you find other properties until they make a combination of the four cases of congruency that I showed you in the beginning. Moving on. So here we have another case of congruency. We have two triangles again, and we have to prove that they are congruent, right? What is the first step? By now, you should know what is the first step. And if now you think maybe you can understand this, try to solve this one on your own first. So in triangle ABD, you see this triangle here? I'm calling it ABD. So in triangle ABD and triangle what? DBC. Let's call it CBD, yeah. Triangle CBD, right? So here we go, right there. I have to mention three things that are the same in these two triangles. So let's start with this one here. Things don't have to be in order. You can start anyway. So you see this line AD, this one here, AD. Yeah, I have AD. I'm saying it's equals to what? To this line here, DC. It's equals to DC. What is my reason? This was given. It was given to me. Right? Perfect. Now let's erase this so that we can see other things now. Perfect. Now what else is the same in these two triangles? Look at this line here. See this line at the center here? This line there, it's called DB. So this triangle has a line called DB and this triangle has a line called DB. Make sense? Yeah. So I have DB. I'm saying this DB must be equal to the DB in the triangle. How do we know that? What is the reason? This is the common side. It's the common side. This is the side that is shared between these two triangles, right? And then after that, what else can I prove to be the same here? It might be a tricky one, but after doing several examples of this, you will be able to see it much easier. So you see this angle B1. B1, it's in this triangle here on the left. So let me write that here. How much is angle B1? With this symbol here, it tells me that this angle is 90 degrees. Right? So if this angle is 90 degrees B1, what will make B2 now? B2 is obviously also 90 degrees because if these angles are on a straight line, they're supposed to add up to 180 degrees. So B1 is 90 degrees. It means B2 is also 90 degrees. So let me write here too. B1 is equals to B2, right? And how do I know that? It was given. This thing here, this symbol of perpendicular, it's giving me that angles are 90 degrees. So if the angle here is 90, it means also here it's 90. So it was given to me that the two angles are equal, right? And then now, after proving three things, I can make a conclusion. Now I can say, therefore, triangle ABD is congruent to triangle CBD. And now I have to provide a case of congruency. What did I prove here on this side? I proved two sides to be the same. Below here, what did I prove? I proved two sides to be the same. And then below here, what did I prove? I proved two angles to be the same, right? And then I have to come into a conclusion now. What case of congruency is this? Did I prove a side angle side? No ways, because for a side angle side, I must have a side, an angle in between, and a side. So if the angle that I proved, it was not an angle that was between the two sides in a triangle, then that's not side angle side. So now I have to rediscover again. This 90 degrees, it's what? It's a right angle. So I can represent that with R, right? And then this line AB, AD, it's opposite to a 90 degrees. And this line DC, it's also opposite to a 90 degrees. What do we call sides that are opposite to 90 degrees? We call that side a hypotenuse. So we are saying here, this is a hypotenuse. And then we said that this is a right angle. And this is a side, right? So this provides to me that this is RHS as a case of congruency. So I have RHS.